This is the Constellation Quarterly Report for February 2009. The Crew Exploration Vehicle, Orion, has reached a major milestone with the development of the Launch Abort System. Capable of pulling the spacecraft and its crew to safety in the event of an emergency, the Launch Abort System is set for a full-out test in 2009 at the White Sands Missile Range in New Mexico. Called Pad Abort Test 1, the test firing will lift an unmanned Orion test vehicle. The Orion abort flight tests are a critical link in the development of our nation's next crew-piloted spacecraft. The rockets used in that system have already been successfully test-fired in preparation for that flight test. The test firing, taking place at the Alliant Tech Systems facility in Utah, was the first time a motor with reverse flow propulsion technology at this scale has been tested. It also is the first test of its kind since the beginning of the Apollo program. At the Dryden Flight Research Center in California, mass property tests were performed on the Orion test crew module, which will be pulled by those rockets. The mass property test determined how the test module's weight is distributed by taking measurements at 3 points with the module tilted at varying angles. The related moment of inertia tests gauge the module's resistance to rotation by forcing small rotations and precisely measuring the resulting motion. The tests allow engineers to accurately predict how it will behave when launched during the pad abort test. It will also give engineers a better understanding of how the Orion will perform during a flight, providing valuable information for the design of Orion flight modules. The first set of gantry steel for the Orion launch pad arrived at the White Sands Missile Range site this quarter. The gantry serves as a combined launch pad and simulated launch vehicle. Since the pad abort scenario involves aborting from atop a launch vehicle that has not yet ignited, the gantry can also simulate the launch vehicle to the Orion test module. Also in support of the pad abort test is the Jettison Motor Burst test, conducted in Sacramento, California. Engineers use the test firing to verify that the motor meets specification requirements and to help define induced acoustic, vibration, and shock loads caused by the motor. At the Kennedy Space Center, preparations were being made for Ares 1X, the first test flight in the development of the Ares 1 rocket. This flight test will provide aerodynamic data crucial to the design of the Ares launch vehicle. It also provides valuable hands-on experience to engineers and technicians for the eventual preparation and launch of the Ares launch vehicles. A new firing room was unveiled featuring state-of-the-art technology. Using checklists and procedures stored purely electronically, the Ares 1X launch will include the first paperless countdown. Segments of the Ares 1X upper stage have arrived at Kennedy and are being processed in the vehicle assembly building. KSC also saw the completion of the first of 3 Lightning Towers, composing a lightning protection system. The towers are designed to help deflect and discharge lightning away from the Ares 1 rocket during launch activities. Fabricated steel began arriving at NASA's Stennis Space Center by truck for construction of the A3 test stand that will be used to test the engine for the nation's next generation of moon rockets. Within days, workers began assembling the 16 steel stages needed on the foundation and footings poured in 2007. By the time the initial phase of construction is complete in April 2009, some 4 million pounds of fabricated steel will be in place, and Stennis Space Center will have a towering structure that will be used to test the J2X engine currently in development. The Altair Lunar Lander, the vehicle which will carry 4 astronauts to the surface of the moon, saw its request for proposal released. This will engage outside industry to help in the final design of the spacecraft. Apollo astronauts paid a visit to the NASA Johnson Space Center to get a first-hand look at the proposed layout of the lander and to discuss lander concepts with the team. The Altair will be able to stay longer and land in more locations than the Apollo-era spacecraft. While living on the moon in lunar habitats, astronauts will need to produce oxygen. NASA scientists successfully extracted oxygen and hydrogen from volcanic soil in Hawaii. The tests proved the technology that might help lunar habitat crews successfully conduct long-term missions on the lunar surface. Other lunar gear, such as rovers, spacesuits, and tools, were demonstrated by the Desert Rats team in Arizona. RATS stands for Research and Technology Studies. Mission scenarios are conducted in remote desert locations, simulating the terrain of the Moon and Mars, and help engineers drive out requirements for future exploration equipment. Constellation is engaging the talents of NASA centers and industry partners across the United States to develop spaceflight hardware. The program will reach a major turning point in the coming months as it prepares for its first flight tests.